words. So this is what I thought they were getting at in that previous slide, because it had per, the word per. So some common words and how to interpret them. The word per means division because it means for each one. And so you imagine dividing by each of these objects and saying for each one, what do I have? So that's per. So miles per hour, miles divided by hours. You read it as miles per hour. And there are several keywords. Of, or the hyphen, that's multiplication. Okay, here's another one, kilowatt hours. Kilowatt hours. Yeah, so that is, let's see, kilowatt, the watt is a unit of power. And power is work divided by time. So if you multiply power by time, you get work. It's actually ends up being the same units as if you were pushing over a distance at a constant force. It's how the unit works, but we call them kilowatt hours. And so this is actually really important if you were considering something like your electric bill. You get charged per kilowatt hour. And so what happens is you have a 60-watt light bulb, and you run it for a certain amount of time. You can figure out how much it's going to cost you. A 60-watt light bulb. If I run it for, let's say, 16 hours. Yeah, something like 16 hours. That should be something like 16 times 60 watt hours. And that's about 1,000 watts. That's a kilowatt hour. So then you can say if I'm being charged 18 cents per kilowatt hour, I'm just making up a figure. I don't even remember. I can't even estimate to what it is because I never look at that stuff on my electric bill. But if it's 18 cents per kilowatt hour, then I know it costs me 18 cents to run that light bulb. That seems too high to me. I don't think that's realistic, but I may be wrong. I do know my electric bill is really high. but I actually don't know what the actual condition is. But does that make sense? Like you take the watts times the hours, it gives you watt hours. For kilowatt hours, it's a little bit different because it's supposed to be 1,000 watt hours for the kilowatt. So we do something a little bit different. Okay, but the hyphen there is meaning times. Squares, so square feet. When you say square feet or feet squared, that means it's just that thing times itself, raising the power to. Okay, so if I have a little plot of a garden and it is 3 feet by 6 feet, and I want to get enough garden soil, buy it at Lowe's or Home Depot or something like this, buy enough garden soil to fill up that plot with a flower bed or something, I need to figure out what my square footage is that I want to cover. Well, it's 3 feet by, it's another keyword, 3 feet by 6 feet. So the units are going to be feet times feet. And here, 18 squared, it would be 18 square feet, or 18 feet squared. Okay, cube. We have cube. So that's the natural unit for volume. Feet cubed, or cubic feet, cubic meters. cc's, that's cubic centimeter. This stuff is actually quite useful for just understanding things around you. So if you look at metric system, liter. So a liter, if you take 1,000 of that, that's a milliliter. That is the same as a cubic centimeter. They just mean the same thing. A milliliter and a cubic centimeter are the same thing. It's just one of them you're thinking about a fluid, and the other one you're just thinking about a region of space. But they mean literally the same thing. It's both volume, and it's the same amount of volume. 1 centimeter by 1 centimeter by 1 centimeter. So cubic centimeter. We call it cc also. So lots of ways to refer to these things. Okay, so let's look at unit analysis to try to figure out this. Look, here we go, apples. How many crates do you need to hold 2,000 apples if each crate holds 40 apples? So there are units in here. There are units in here. So somebody give me some unit that you see in the problem. Yes? Apples per crate. Yeah, apples per crate. That's a good one. So the apples per crate, that's the 40. just the units. Okay, so if I take apples per crate and divide by apples. I know, I'm just, giving you a hard time because it's useful. Because it's useful. Apples per crate on bond, that's what you need. So, okay, let me go through all these possibilities, so let me try to bring it up and I'll try to do a better job here. Actually, painting is already good. I'm gonna use painting, it's the best tool possible for this. I don't know how thick my pencil is. Can I get it big like this? Yeah, I can. Okay. So, we're talking about apples, which I'm just gonna write A, P, P, because it's hard to write this. That's one of our units, and another one is apples, I could just type too. Apples per crate. Oh, look, crate. Because I need the R, right? Crate. Crate. I don't know, I do like to do this stuff with my kids. I also like to play with my kids with inflationary language. You know what that is?
Mm-mm.
Has anybody ever heard of that? Anybody guess what inflationary language is? I'll give you a hint. In inflationary language, you would say crate as crenine. Does it make sense now? For any word, if part of it sounds like you're saying a number, you replace it with one larger. So instead of that's great, that's crenine. Right? That's inflationary language. So I say stuff that my kids never get it. They never get it. So apples per crate. Apples per crate. I'm gonna switch to the text. These are our two units, and we've got to think, how can I combine these in such a way to get an answer that's crates? And remember what the slide said a couple slides ago, we're only allowed to combine these by things like raising the powers or multiplication and division. You can't take apples plus apples per crate and get anything sensible. It's just like taking apples plus oranges. Now, I guess you could get fruit out of that, but that's a different sort of analysis. That's a different sort of analysis. So we want to combine these in some way to get crates. Does anybody have an idea how we do it? Yeah. You do divide, okay, so which by which?
We'll work with, how many times, what this is,
Yeah. By apples per crate. By apples per crate. So here's the thing. The answer should be given like this. Take this quantity, divide by this. I'm ignoring the numbers for now because the units are going to tell me what to do. I know I need to answer the crates. What happens if I divide these fractions? Apples divided by apples per crate. You divide by a fraction, what happens? That's the same as what? Multiplying by the reciprocal. Exactly. I mean, same thing. So we take apples times, so apples, okay, I'm too lazy to just hit the button. Apples times crates per apple. And now that we have the apples here on the bottom and on top over here, because there's an implied over one, now these things cancel and you get the right answer. So it tells you what to do. Here's one. This one is hard on the brain, I think. But what about this one? If I'm going to Pensacola, 600 miles, if I'm driving 100 miles per hour on average, how many hours does it take me to get there? Six, right? That one is less confusing because it's more familiar. But it's the exact same concept. I have miles, 600 miles. I have miles per hour, just like apples and apples per crate. I have miles and miles per hour. What's the only sensible